welcome to Econometrics Melody. In this video, we will discuss some of the important topics related with probability. First of all, let us begin with the definition of a probability of an event A. This is equal to the number of favorable events, and we divide them by total possible events. Total possible events, and this is also called H, sample space. And let us divide the number of favorable events by F, and then total possible events they are called is sample space. Sample space, it is denoted by years, and it is the set of all the possible events. And let us express them in terms of their cardinal number. So cardinal number of the total favorable events divided by the cardinal number of the sample space. And let us say it by the help of an example. So when we toss a coin, two outcomes are equally likely. We get either head or tail. They are mutually exclusive events because both of them cannot occur at a single time. So the probability of getting head is equals to the number of favorable events divided by the number of total possible outcomes. We have one head divided by the total possible outcomes. So it is 50% of the time that we expect to get head. Similar is the explanation for the tail. So for an unbiased coin, the probability of getting head and tail that should be equal 50%. Now, if we sum the probability of the events in the sample space, then that should be equal to 1. Now, let us see another example where we have a container which contains 7 identical papers. Contains the name of the days in a week. We have 7 identical papers. Now, when we draw one paper, so what is the probability of getting, let us say, Sunday? Here, the cardinal number of the sample space is equals to 7, because in a week we have 7 days. From Sunday to Saturday, it is an equally likely event. So the probability of getting Sunday or the probability of getting any days in a week, that should be equal. So let us apply the formula. The total number of the favorable events divided by the total of the outcomes. So we have one Sunday in a week and divide it by the total outcomes, that is 7 days in a week. Similarly, what is the possibility of getting Saturday? So let us apply the formula. Number of favorable events divided by the number of sample space, the cardinal number of sample space. We have one Saturday in a week and there are total 7 days in a week. Similarly, if we add the probability of all the possible outcomes or events in a sample space, that should be equal to 1. For this particular case, is the events are equally likely, probability of each event is equal to 1 by 7, and there are 7 such events, and if you operate this properly, so the sum of the probability of the events in a sample space within a sample space, that should be equal to 1. Now, let us reinforce this concept by the help of another example. We are going to toss coins, and when we toss coins, whatever outcomes we get, that is equivalent to tossing a single coin 2 times. As we have seen, there are 2 possible outcomes when tossing a coin, either head or tail. So when we make a second toss, then after we are going to collect the events. We toss a coin for a single time, then we get either head or tail. Similarly, if we have head at the first toss, then again there are 2 possibilities. We get either head or tail. When we get head at the first toss. Similarly, if we get tail at the first toss, then again we have 2 possibilities. We get either head or tail at the so the combination of these events or the final event, so they are either we get head or we get head tail, or we get tail head or we get tail tail. So these are all the possible events. Our cardinal number of the sample space is 4. And as these events are equally likely, the probability of getting this event, let's call it A, this should be equal to 1 by 4 for each of them. And let us use the formula. So what is the probability of getting head? And this should be equal to the number of favorable events divided by the number of samples, cardinal number of sample space. The favorable event H. So we encounter this event only one time divided by the sample space, 1 by 4, 25%. Similarly, if we operate it and if we want to find the probability of getting tail, so the probability of getting tails on both the coins, so this is also equal to the number of a favorable event divided by sample space. So the probability is 25%. Again, if we add the probability of all the events in our sample space, this will be equal to 1. For this particular, there are 4 identical likely events, and each of them have the probability of 1 by 4 or 25%. So we multiply 25% by 4, we get 100%. This is again very simple. By the help of this experiment or with reference to this experiment, let me introduce the concept of random variable. So let us focus on the number of heads. In these events, so let us count the number of heads. So the possible numbers of the random variable that is going to take it from 0 to 2, 0, 1 or 2. So we can see no heads, or we can see one head, or at most two heads. Now let us write the corresponding frequencies, or let us first write the events. 0 head means, and then one head, we get one head either event or this event qualifies for this condition, and both heads is event qualified. Now let us write their frequency in terms of their frequency. One event, two events, and then again one. And let's write their probability. So when we divide the total number of possible events by the number of sample space, divide the frequency by its by the number of sample space, that we get the probability. And 25%. And if we add the probability of all the probabilities of all the events, or if we add the probabilities sample space, then that should be equal. For each element in the random variable, we have their corresponding frequency. Now let us plot them in a graph. In x-axis, we're going to plot the random variable, and in y-axis, we're going to take the frequency. Our random variable, it ranges between 0 to 2. The range of the frequency, it also ranges between 1 and 2. For 0, when x is 0, our f is 1. So let's take this point. And when x is 1, we get the maximum point, our y is. And when our x is 2, again, let us join these 3 points, making use of some curve. If we go on tossing the coin for n number of times, then this graph would be a bell-shaped curve. So if we toss a coin for n number of times, then the observation of the elements in our random variable, it will increase, or it ranges from 0 to n, and then our graph will gradually take. This part we're going to explore in some other videos as well. So this is it for this tutorial. Thank you very much for your time. Thank you very much. Econometrics Melody.